Welcome, everyone. I'm thrilled to have you here. Today, we are going to dive deep into a critical component of modern AI applications, text splitters. Specifically, we'll master the logic behind semantic and character-based chunking. Let's get started. Let's start with the absolute basics. When we build retrieval-augmented generation, or RG, systems, we feed documents into our LLMs. But LLMs have a hard limit on the amount of text they can digest at once, known as the context window. If your document is 100 pages long, you simply cannot feed it all in one go. This is where text splitting comes into play. It is the process of breaking long documents into smaller pieces. But here is the critical part: we cannot just chop words in half. Our primary goal is to maintain the semantic integrity of the text, ensuring that related information stays together. To achieve this, we use specialized tools called text splitters. Looking at this diagram, you can see the journey of our data. We start on the left with a massive, unmanageable large document. It passes through our text splitter, which acts as an intelligent filter. The splitter breaks the document into bite-sized pieces, chunk 1, chunk 2, and chunk 3. Finally, these chunks are perfectly sized to fit into the LLM context window on the right, ensuring our model processes the information efficiently without hitting token limits. Now let's zoom in on our first major strategy, character-based chunking. How does a computer know where to cut the text? In LangChain, we rely on a brilliant tool called the recursive character text splitter. The logic here is beautiful in its simplicity. It works by taking a prioritized list of separators, starting with double new lines for paragraphs, then single new lines for lines, and finally spaces for words. It attempts to split the text at the highest level first, the paragraph. If that paragraph is still too big for your defined chunk size, the splitter recursively falls back to the next separator, breaking it by lines and then words if necessary. This ensures chunks are small enough while respecting the natural structure of human writing. This flowchart maps the exact decision logic of the recursive splitter. We input the text and immediately ask, does it exceed our maximum size? If yes, we try splitting by paragraph. We evaluate the size again. If it's still too large, we fall back to splitting by line. We evaluate once more. If it's still too big, we split by space. As soon as a piece of text fits our size constraints, it exits the loop and becomes a final chunk. It's a highly efficient, cascading safety net. Let's put this into practice with some real Python code. Here we import the recursive character text splitter. We initialize it with two critical parameters. First, chunk size equals 1000. This dictates the absolute maximum characters our chunk can contain. But look closely at the second parameter, chunk overlap equals 200. Why do we do this? Imagine cutting a sentence perfectly in half. The meaning is destroyed. By enforcing a 200-character overlap, the end of chunk A becomes the beginning of chunk B. This overlap acts as contextual glue, ensuring that ideas spanning across the split point are preserved. It's a simple parameter, but it massively boosts the quality of your AI's comprehension. Let's visualize how overlap works. The top box represents our original continuous text. Below, we see the generated chunks. Notice how sentence 2 exists at the end of chunk 1, but it is also duplicated at the beginning of chunk 2. The same happens with sentence 3 between chunks 2 and 3. This duplication is the overlap in action. It guarantees that the AI has the surrounding context, regardless of which specific chunk it retrieves from the database. While recursive character splitting is a fantastic default, we need to talk about its limitations as senior engineers. The harsh reality is that counting characters is a blunt instrument. Sometimes, a single complex thought spans across multiple paragraphs. Character-based splitters don't understand meaning, they only understand size. Consequently, they can split text at incredibly awkward positions, completely breaking logical units. When you break related concepts apart, your AI experiences severe knowledge gaps and retrieves irrelevant data. To solve this, we must graduate to semantic chunking. Instead of looking for punctuation, semantic chunking analyzes the underlying meaning of the text, intelligently grouping sentences that belong to the same topic. Compare the two approaches on this diagram. When we feed a text block into a character splitter, it simply chops it at 1000 characters. It's blind to the context, resulting in a broken thought, highlighted in red. But follow the path down to the semantic splitter. It actually analyzes the meaning of the words. It waits for a natural shift in the topic before making a cut. The result, highlighted in green, is a chunk that fully preserves the context and meaning of the original author. So, how exactly does semantic chunking read the mind of the text? It relies on a fascinating four-step logic. First, it breaks the entire document down into individual sentences. Next, it uses an AI embedding model to convert these sentences into high-dimensional numerical vectors embeddings. Step 3 is where the magic happens. The system measures the semantic similarity between adjacent sentences. Think of it as calculating how closely related sentence A is to sentence B. Finally, it scans for natural breakpoints. If sentence A is talking about apples and sentence B is suddenly talking about car engines, the semantic similarity score drops drastically. The system detects this drop, realizes the topic has changed, and strategically slices the text right there. This timeline perfectly illustrates semantic boundary detection. We see sentences 1, 2, and 3 have high similarity. They are grouped into chunk A. However, look at the transition between sentence 3 and sentence 4. The system detects a massive drop in similarity A breakpoint. Because the topic shifted, the algorithm severed the connection, starting a brand new grouping, chunk B, with sentences 4 and 5. It's mathematical topic modeling in real time. Implementing this in Python is astonishingly elegant. We import semantic chunker and initialize it. Crucially, we must pass it an embedding model, like OpenAI embeddings, because it needs that model to calculate the similarities. Now, let's talk about a highly important real-world use case, legal contract analysis. In law, a single indemnification clause might span 3 long paragraphs. If we use a character splitter, it might slice the clause right down the middle, separating the condition from the penalty. If an AI retrieves only half that clause, the legal advice it generates could be disastrously wrong. By using semantic chunking, the system recognizes that those 3 paragraphs share semantic cohesion and keeps them bound together as one robust chunk. In this architecture diagram, our legal contract enters the semantic chunker. The chunker communicates with the embeddings model to evaluate the text's meaning. Instead of arbitrary text blocks, the output is beautifully organized by concept, clause 1 covering liability and clause 2 covering termination. These conceptually whole clauses are then stored safely in our vector database, primed for highly accurate retrieval. To wrap up our deep dive, how do you choose? It comes down to ROI. Use recursive character chunking when you need speed, have a limited API budget, and are doing basic Q&A. It is computationally cheap. But pivot to semantic chunking when you are dealing with complex technical manuals, medical records, or legal texts where precision is non-negotiable and you have the compute budget to support embedding generation. Your ultimate success depends on matching your strategy to your data. Thank you for joining this deep dive. I invite you all to like, subscribe, and visit quicktechie.com for premium certification prep, including our extensive Q&A banks, full ebooks, audiobooks, full-length training courses, and exclusive interview guides. Keep building, and I'll see you in the next session. This final decision matrix is your cheat sheet. Evaluate document complexity. If it's low or your budget is tight, follow the path to recursive character chunking. If complexity is high and precision is paramount, follow the path to semantic chunking. Both paths lead to deploying your RAG system. And to master more architectures just like this, follow that final arrow straight to quicktechie.com. Please like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see this is all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper, it would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni, these people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message, you can call us on this numbers as well.